Hello everyone, I'm Vinay and welcome back to AI Champ YouTube channel. In this video, we'll be learning about Pandas library. But before that, I want to tell you that it is very similar to NumPy and it uses a lot of common features as we have in NumPy. So if you haven't checked out NumPy, we have created a couple of videos for that. You can have a look at that first and then come back to this video again. So we'll be learning about data frames, series, some common functionalities such as map and apply, reading CSV file, reading and storing CSV files, and some other ideas such as Boolean filtering. So let us just jump and dive and understand what this pandas library is all about. The pandas specifically is used when you have some tabular data. This is column 1, this is column 2, and things like this. And you have some rows also. So generally, this is very standard data, especially in machine learning. You'll find a lot of CSV files or Excel sheets which contain some data. And to process such data, we need this library pandas. So now to start, first we need to install Pandas library. So to install the Pandas library, I have connected to my virtual environment and let us just install Pandas that you can easily install using pip install Pandas. So in my case, it is already installed. Now let us create a Jupyter notebook to write some code. We have opened this Jupyter notebook and first thing what we need to do is we need to import pandas. So we're just importing it. So we are importing it as import pandas as PD. Along with this, we also need NumPy for our code. We are just importing that as well. Now I'm assuming that you already have NumPy installed, but in case if you haven't, then it is as simple as pip install NumPy. Let us just run this code. So now the first thing what we want to do is we want to read this particular CSV file that we have obtained from Kaggle. Let us just try to read that. So I'm creating a variable called as df. So generally you'll see a lot of this name in Panda. So it is nothing but a data frame pd dot read csv, and we just need to pass the file path. So in our case, it is Netflix titles.csv, and we have obtained our first data frame in pandas. So now if you want to look what kind of data this particular data frame has, then we have a couple of functions. So we can use df.head. So what this does is it actually gives you the first 5 rows of this CSV file. If you want more, you can pass it as like 10. So it will provide you 10. So by default, it is 5. And there is one more function called as tail that gives you the last 5 rows. And this also you can get maybe 10 or 12 rows depending on what you pass. By default, it is 5. So here we can see that there are like lot of columns and some data. Now, what if we want to see what all the columns in this particular CSV file? So we can simply use df dot columns and see that, okay, this has this show underscore id, type, title, director, and all these things as column names. Now, if you want to check all the data types of these columns, what you can do is you can simply write df.dtypes and you'll obtain all the data types of each column in particular. So in this case, show underscore id is an integer, and rest all this object, it actually means that it is some sort of string. And there is release here, that is also integer. Now suppose if you want to check all the integer data types and their count, standard deviation, mean, and all those things, that you can easily do using df.describe method. So in our case, there are two columns which contain integers, and then it is showing us that, okay, you have 6234 such rows wherein you have release underscore year column, then the mean of it and all these things. So in this case, mean is 2013.35. So most of the movies are around this, or maybe you can say that the mean is 2013 something. Now, if you want to see how much rows and how much columns this data frame has, you can simply write df.shape and you'll get that, okay, there are 6234 rows and 12 columns. Now, if we see this column, so here we can see that, so there is this type column which gives you the detail about the show type, whether it is a movie or TV show or something else. So let us just try to understand from this data a bit more. So if we want to see what all types are there in this data set, so we can write df dot type dot unique. So type in our case is the column name. Okay, so we have seen that there are only two type of shows in this case. uh, Instead of writing this, we can also write it like df and square braces, and inside it we can write the column name also. And this is also same as the above code, so it provides us the same thing. Now suppose if you want to know how much movies are there and how much TV shows are there in this particular CSV file, so what we can do is we can write this either as df.type or df square braces, and inside it write type, and we use this function called as value underscore counts, and this gives you the detail about movies and TV shows. So in this case we understood that, okay, there are around 4265 movies and 1969 TV shows. So this is just a basic overview of pandas. Now let us try to understand what a series is, what a data frame is in more deeper level. So when we load any CSV file or any data, we know that it is some sort of tabular format. So these are all columns and these are all rows. So there will be always some column name, like in our case it is type, show ID, and so on, and all the details will be here for each uh, movie or TV show. So name, so in particular, let us say name Toy Story and all these things. So for each show, we have all the details like this. So when we load this data in pandas, so that is what we understand as data frame. So data frame is nothing but just a data type that we get in pandas, and it offers some functionality. And when we say about one particular column, so this whole thing is a data frame. And if we take one particular column, like if the data frame is df, and we take df dot type or df square braces and type, so we get all the data of a column. So this is nothing but series. So series are very similar to NumPy arrays, lots of common functionality between both of them. So let us now try to understand this series and write some code. So let us just create one NumPy array, np.random.rand int, just randomly creating a NumPy array out of this code. We just need, okay, so let us see. Okay, so we have obtained one random NumPy array, and what we can do is we can simply create a series out of this NumPy array. Let us call it as S, and we just need to write pd dot series, and we just need to pass this NumPy array. And we will see that this NumPy array, all the data is in this column 1, 5, 1, 8, all these things. And we have something else along with that. So that is the index. So this 0 is index, 1 is index, 2 is index, and so on. So what if we want to get a certain data? So this is very similar to NumPy indexing. As of, let us say, 0, we get the value 1. index is 1. So by default, this index are from 0 to n minus 1 length of the array, but we can also provide our own specific labels, or you can say indices. So let us create labels equals a, b. We have created 5 uh, labels or indexes that will be using. So we have already the numpy array as a, so we just need to create pd dot series and just need to pass the numpy array, and index we set as labels. And now if we see the s, so instead of 0 1 2 3 4, we have a b c d e, and if we want to get particular value, so we just need to use this curly braces and use, say, a, s of a, and so on. We can also get the same thing using s of 0 also. So this normal integer index that will always be there, but we can have specific label set to it also. Now let us try and understand how to create a data frame out of some data. So let us just create a data on Python from Python list. So let us say just we just keep some names. We are just randomly putting some names out there, and let us create one more numpy array randomly, and range from 145 45, and size same as the above numpy array. And yeah, let us try to see what this a and b is. So we have some names: Vinay, Kuldeep, Abhishek, Siddharth, and Viren, and some b as some random numbers: 14, 30, 27, 19, 27, and so on. And now suppose we assume that these are the names of some people, and this second array is their current balance. So, and we want to create a tabular arrangement, that is a data frame out of this data. So what we can do is we can simply use this df is equals to pd dot data frame, and we just need to pass the column name, so in our case is name, and give this uh, list a as our names, and balance as the list b. Now let us try to see this data frame. We have created this tabular arrangement data frame with name and their balance. Now let us try to see some code around this data frame. If what if we want to get all the names, so we can simply use df dot names, or df square braces and names. Okay, so this should not be names, but rather it should be name. So we obtain same thing. So this is a series object. If you want to see type of df dot name, then you'll see that this is a series data type. So series is very similar to numpy arrays. Now let us say index. If you want to get the first name, what we can do is df dot name and just pass it as 0, and we'll obtain the first name. We can also perform indexing and slicing, all those things that we can do in numpy. We can simply use this df dot iLoc method, so index location, and we just need to pass a proper rows and columns. So suppose if you want to get the first two rows and all the columns, so we can simply use 2, and we get all the columns. And suppose if you want to get only the first column, then we can pass 0 here. So in our case, let us keep it as all columns. We can use this or just do this. Instead of using this I location method, we can also use df dot loc method. So suppose if we want to get only the balance, then what we can do is we tell that we need all the rows, and we just need to pass this particular column name here. So in this case, we obtain this balance like this. We can also perform some Boolean filtering. So let us see that from our data frame. Suppose if we want to get all the people who have balance more than 20, so we can simply use Boolean filtering. In our case, let us just take the column or the series, and if this is greater than 20, and we can see that okay, for two people it is not true, and for three people it is true. Now if you simply pass this as df.loc and pass this boolean filter thing in df.loc, then we'll obtain all the people who have balance more than 20. So there are two more functions that are very important and we need to understand. They are map and apply. So suppose we have this data frame again. These are calls, column names, and these are rows. So name, balance, and so on. Things are there. And suppose if you want to make all the changes in a particular column or series, so all the values, let us say that there are some names like Vinay and all this, and we want to change this to uh, AI champ Vinay, something like this. We want to modify data of all of it, or maybe just change the balance or something like this. So that we can easily do using map function. And suppose if you want to add a new column or something like that using all the row data, so that suppose there is new balance and we want to increment everyone's balance using some logic and increment it by 20% more. So if it is 100, it should be 120, something like this. And for everyone, new balance should change. So here we use apply. Let us see this in practice. Let us again see the data frame that we have. So we have data frame df. Fine. Now let us try to see what this map functionality does. So df name. So we are changing this particular series and we're setting it as df name, and this is a series object and we're using map, and here we need to pass a function. So in our case, let us just create some lambda function and we just append AI champ to this particular data. So this is a way to write a function. So this is similar as AI champ. I'm just writing something. So X and return AI champ plus X. So this particular function is same as this one, just that lambda functions do not have name. So we can simply pass this also AI, append AI champ as this, or we can also use this lambda function. So we have changed this name and appended AI champ to everything. So X is nothing but individual elements. So in first case it will be Vinay, second case it will be Kuldeep, and so on. So, and for every item that we have in this column, we are appending AI champ text to it. Now let us just see the data frame. You can see that okay, there is AI champ and name is appended to it. The same thing can happen using this function also, like append AI champ, and yeah, we again append the same thing twice. Fine. Now let us see the apply function. So again, here also we need to pass a function. So let us just create one change balance function, and so here we get all the row data, not just a particular element of one column, because in map we are we are getting data only from one particular column, but in this case we are getting all the rows data, as in we get the data of name also as well as balance also. Let us just create new balance change balance function. So let us write row, we are just creating a column every time, and new balance we change it as, so let us just row and balance. So we get the balance and we just multiply it using 1.2, so that we change it by 20% and we just need to return the row. This is one of our function. What we are doing is we are getting all the row data, and we're just simply increasing the new balance. So we can add all the logical conditions in this particular function. Now simply df dot apply. So in our case, we are applying it on the whole data frame, and we just need to pass this change balance function, and access equals columns. And yeah, if we see that, okay, we have obtained a new balance column in this case, and it is 20% increase. Okay, so that is it for this video. I hope that you have understood all the basic details of pandas. If you haven't checked out the numpy video, do check that out first. You'll understand a lot more about the indexing and slicing, all these operations, and is very similar to this pandas series, and you can use that. Along with that, if you want to just store this particular data frame, you can just use this particular data frame and to CSV, and just the CSV file name like abcd.csv, something like that, and that is it. You just need to run the code, and you'll see that one of your CSV file is created from your data frame. So thank you again, and see you in the next video.